In this video, we'll be looking at formation of differential equation. That is, we want to form this equation, this differential equation that is here from this. We want to form this equation here from this. And how are you going to do it? So that is why we call it formation of differential equation. And how will we go about it? We can do this by eliminating the arbitrary constants. What are the arbitrary constants? This A and this B. Because if you look at this equation that is here, did you see any A, any variable of A? Did you see it here? Or any variable of B? Did you see it there? No. We need to eliminate it. That is, we need to find a means of removing this arbitrary constants A and and B. Then there are some things that are also present in the equation, like the dy dx. Here you can see that is there, so we need to get our dy dx. We need to get the square y, the x square, so we need to get it from this equation. Okay, so we proceed. Then given that y equals to ax squared plus bx, right? So as I've said that we need to remove this a, eliminate this a and b that's there. And we also need the derivative, the first derivative and the second derivative that is there. And to do that, to get the first derivative first, we need to differentiate once. We first of all differentiate it once, then differentiate it for the second time to get this. Okay, so if I differentiate this for the first time with respect to x, I'm differentiating y with respect to x. You can see that from this equation is y with respect to x. You can see. So if I differentiate this equation with respect to x, I will have this. That is, using the general method of differentiation, I will use the power here, which is 2, to multiply it, then subtract 1 from the power. So that will be 2 times ax. Then if I subtract 1 from the power, that will be 2 minus 1. So that automatically that will give us 1. So that will be 2ax raised to the power of 1. And x raised to the power of 1 will give us x. So that is 2ax. What about if I differentiate bx? If I differentiate this bx, I'm differentiating with respect to x. So I will use the power of this x, which is 1, to multiply this b. That will give me b, right? Times x raised to the power of, I will subtract 1 from the power. So that will be 1 minus 1. And that will be x raised to the power of 0. So x raised to the power of 0 is 1. So 1 times b, that will give us b. So that is how we arrive at this b here. So this is the first derivative. Now we have gotten the first derivative that is there. What about the second derivative? This second derivative. Now, do you know the reason why this doesn't change to 0? Why I was differentiating with respect to x? If I'm differentiating with respect to x, a will be constant, right? So because this a is being attached to this x squared there, and this b is also attached to x here, so that is why they don't change to 0. But anyone that does not have x will change to 0, right? Okay, so to differentiate for the second time, for the second derivative, we have what? We have this. Why? Because I'm now differentiating this for the second time, and I'm differentiating with respect to x. So anywhere there's no x, we change to 0. Like this b alone now is only b, there's no x at all, so it will change to 0. So now if I differentiate this with respect to x now, this x there has a power of 1. So if I use the power, which is 1, to multiply this 2a, that will give me 2a, right? So you can see it here. So I will then subtract 1 from the power of x. That will be 1 minus 1. So that will be x raised to the power of what? 1 minus 1. And 1 minus 1 will give us 0. And that will be x raised to the power of 0. So x raised to the power of 0 will give us 1. So if I use the 1 to multiply this same 2a, it will still give us 2a. Now you can see that we have gotten the first derivative, which is this, the y dx, and we have gotten the second derivative, which is this. Now we need to eliminate this a and what? And b. And to eliminate a and b, now if you look at this very well, this second derivative, you notice that I have a here. So I can easily make a subject to the formula here. I can easily make a subject to the formula. Why from here now? There's no I can make B solid of the formula because B is here, right? Here it does not have B. So I will just make A solid of the formula here. While here I will make what? B solid of the formula here. Okay, and to make A solid of the formula, what will I do? I will do what? I will divide both side by 2. And so I will have what? I will have this. So if I divide both side by 2, this second derivative, this is it here. So if I divide both side by 2, I will have something like this. This A divided by 2, you can see it here now. You can see the 2 here. So, and I will also divide this other side by 2, which is this side. Can we see it now? So if I do that, 2 here will cancel what? It will cancel this 2 here. Okay, I'll be left with what? A. So that is A will give us what? To give us this. Now, since I've gotten the value of A, I need to get the value of B so that I can replace A and B. I've gotten the value of A now to be this, so I will replace A with this. And so I need to get the value of B to also replace what? To replace B. And I can get the value of B from this first derivative here because this second one does not have B. So I can get the value of B from this first one here. Yes, from this first derivative here. So that is the value of A. Now to get B, if I make B solid of the formula now, this 2A here will cross to the other side. It will become minus 2A. You can see now. You can see that it becomes minus 2A now. Now I'm now left with B. But mind you that when this B now is equals to this, right? Okay. Now I need to remove this A that is there because we don't want A at all. A is still present here. So I need to remove it. And to remove A, you know that we have already gotten the value of A before. Like we have already gotten the equation for A, if you remember. So we have gotten the equation for A. So I'll just replace this A with the equation of A. So recall that A is equals to this, right? So replacing it now, I will have this. That is, this B now is this. So if I replace this A that is there now with the equation of A, I will have what? I will still have the same 2 here to be this. You can see it now. Why this equation of A now is given to be this. You can see it now. And this X here that is here still remain the same here. You can see it. So this is what we arrive at. This divided dx here is this. So we can see it now. So next thing is to do what? To use this 2 to multiply this one here. And also use this X that is out here to multiply this same one here. So 2 times 1 will give me 2. Right? 2 times X will give me 2X. So you can see how we arrive at 2X here. Everything all over what? All over this 2. Your d square y, the x square remain the same. Why this dy dx here is this. Hope we are following. So these 2 here cancel these 2. I'll be left with x. So you can see now that we are left with x here. Okay. So that is dy dx minus x, the square y, the x square. So I've already gotten the equation for B now to be this, and we have gotten the equation for A earlier to be this, right? So I will substitute A, I will replace A with this, and I will replace B with this, so that A and B, replace them. Now if I replace A that is here, mind you that the x square here remain the same. I replace this A now with this. This is what I will have. I've already this A now. You can see this is A. This is the equation for A. Why this same x square beside this A remain the same here? You can see it now. Okay. Now what about B? I need to replace this B. So I'm replacing B with this now. With this. So if I replace, you can see it now. You can see it here. Why the x here beside this B remain the same to be this. Okay. So if I use this x square here to multiply this 1 over 2, this 1 over 2 that is here, I will have it to be x square over 2. Why the square over the x square remain the same. Just as you can see it here. So plus, now if I use this x now that is here to open the bracket here, that is to multiply both of them. So to multiply the first one here, which is this one, I will have x dy dx. You can see it now. X dy dx. And if I use this same x to multiply this, if I use to multiply this, so it will multiply with this x that is already here before. Mind you, there is already x here before. So that will be give us what? S square. You can see it now. S square d square y over the s square. So that is what we arrived at. And then, yes, now if you look at this equation now, you notice that we need to collect the like term here because of what? We have the square y. You can see that we have the square y here. I mean, we have the square y over the s square here. And we have the square y over the s square here. So we need to collect the like term. Now, collecting the like term, if I bring this one here, if I bring it closer to this, so this is what I will have. And this x dy dx here remain the same. That is, I will bring this one here, which is this. You can see it now. So I will then bring this one to join with this. So you can see it now here. Okay. So that is what we arrive at. Now, having done that, you notice that what is common here and common here is the square y over the s square. So if I factor out the square y, the s square, here I will be left with s square over 2. So you can see it now. I've already factored out the square y over the s square. So I will left with s square over 2 minus. Now if I factor out the square y over the s square here, I'll be left with s square here. So you can see it here now. So this is what we arrive at. Okay. So it's still the same thing here. So it's still the same thing here. Just repeated it here. Okay. So what am I going to have? Now, if you notice that from here, so from here now, let's assume I find the LCM here. This is like over 1. Okay. This is like over 1. So the LCM will be 2, right? So the LCM of 2 and 1 will be 2. The LCM now, this is the LCM, which is 2. So 2 goes in 2 is what? 2 divided by this 2. It will give me what? It will give me 1. So 1 times s square will still give me s square. So you can see it here now. You can see it here. Minus this minus that is there. Now, this one that is there now goes into how many times? That is 2 divided by 1. That will give me 2, right? So if I use the 2 now to multiply this one, to multiply this, I will have what? 2s square. You can see it here now. 2s square. So that is how to find the LCM for that one. Now we have gotten the LCM. What I'm going to do next is to say, okay, s square minus 2s square. What will it give us? You notice that I have s square here, and the same s square is also here, so I can subtract. This is like saying 1s square, 1s square. So if I subtract now, I will have this. That is, if I say 1 minus 2 will give me minus 1. So I will just put the s square that is common in both of them. I will just put it there. You can see it now. So s square minus 2s square will give me what? Minus x square. So that is for that. So the last thing we do is to do what? Is to now use this one. This minus s square over 2. Use it to multiply this. And if you use to multiply this, mind you, the minus here we multiply with this plus here. So it will give, and plus times minus will give us what? Minus. Okay. So plus times minus will give us minus. So this is what we arrive at as our final answer to that. If this minus multiply this plus, it will change to minus. So you can see it here. And the s square over 2 will remain the same here. It remain the same. And I will divide this square y over the s square remain the same. Now quickly, I want to show you something quickly before I end this video. I have some other videos on this same differential equation I would like to show you. So like this one now, question number 1, find the general solution, is already on my YouTube. This second one is already there, this third one is there, this fourth one is there, this fifth one is there, and many like that that I can't even mention. So please, you can watch my videos on those ones. If you have any questions, you can drop it in the comments, and then like the video, subscribe, and turn on the notification button, that anytime I upload this video you can always get notified. All right, see you in my next video. Thank you.